the Earth's moon is still the only foreign celestial body that mankind has ever set foot on. As is well known, the US astronauts Neil Armstrong and Edwin Buzz Aldrin were to immortalize themselves in the history books for all time when in 1969 they successfully carried out the first manned moon landing. Since the only natural satellite of the Earth is quite close to its mother planet, the moon is understandably the astronomical object best studied to date. However, this does not mean that we have already solved all the mysteries surrounding this fascinating satellite. In fact, new findings about the Earth's moon, which are repeatedly recorded by experts, regularly remind us how many mysteries of the Earth's constant companion still need to be unraveled. We'll now reveal to you which groundbreaking discovery terrestrial researchers came across in recent research and how this could pave the way for the colonization of the moon. Want to join us on our journey to the greatest mysteries of the universe? Then remember to subscribe to Simply Space and click on the bell to never miss one of our videos in the future. If you like the content of our posts, feel free to give them a thumbs up. Oxygen on the moon. With its surface pitted with craters and covered in dust, the moon doesn't necessarily seem like a life-friendly celestial body. Nevertheless, in the past, the satellite has repeatedly been the focus of scientific interest when it came to establishing a permanent settlement on an alien astronomical object. Naturally, such a demanding undertaking as the establishment of a lunar base is subject to some extreme challenges. Foremost among these is the problem of providing sufficient resources for the hypothetical inhabitants of the satellite. It is well known that, in addition to water and food, humans need one thing above all else in order to survive: air to breathe. For this reason, researchers have been looking for ways and means to ensure the indispensable production of oxygen on the moon for quite some time. This is how NASA and the Australian Space Agency recently agreed to send a rover to the moon. The unmanned land vehicle is to collect samples of lunar rocks that could possibly provide breathable oxygen. Although the natural satellite of our blue home planet also has a natural protective shell, this is very thin and is also mainly composed of helium, argon, neon, and hydrogen. Consequently, this layer surrounding the celestial body, which strictly speaking is not an atmosphere but an exosphere, is not a gas mixture that could serve as breathing air for humans or other living beings. Contrary to the first assumption, this doesn't mean that there is no oxygen on the moon. In fact, the celestial body is home to large quantities of this chemical element. It is simply not present there in a gaseous state of aggregation. In fact, oxygen on the moon is trapped in the regolith, the layer of fine dust particles and rock that gives the moon its characteristic appearance. Assuming that we succeed in dissolving the chemical element from the regolith, would the corresponding amount of oxygen be sufficient to enable permanent human settlements on the moon? Extracting breathable air. Basically, oxygen is found in many different soil minerals. And in fact, the moon also consists to a large extent of those rocks which we also find on our blue home planet. Even if on the satellite, a larger proportion of the material originally comes from meteorites. In detail, it's minerals such as iron and magnesium oxides, silicic acid, and aluminum that dominate the material composition of the lunar surface. All of these minerals also contain oxygen, however not in a form which could fill our lungs with the necessary air for breathing. Furthermore, the corresponding minerals occur on Earth's satellite in the most variable sizes and forms. In addition to larger rocks, these also include gravel and microscopically small dust particles. What's responsible for the composition of the regolith? Countless meteorite impacts on the lunar surface. Astronomical missiles can crash onto the outer surface of the celestial body practically unchecked, literally pulverizing the crustal rock. In the course of these impacts, the lunar surface also repeatedly experiences admixtures of other materials brought onto the satellite by the meteorites. The bottom line is there is a wide variety of minerals not contained in this form in the original rock of the moon. In detail, the regolith of the moon has an oxygen content of about 45%. As already mentioned, however, the oxygen is chemically bound to the corresponding minerals. A certain amount of energy is therefore required to break up these strong compounds. Let's consider the example of electrolysis. This is a chemical process in which electric current forces a so-called redox reaction. This in turn refers to a reaction in which an electron transfer takes place, which ultimately changes the oxidation states of atoms. Electrolysis is used, for example, to obtain aluminum, chlorine, hydrogen, and caustic soda. In the course of aluminum extraction, oxygen is produced as a byproduct. If such a process were now applied to human use on the moon, the situation would be exactly the other way around. Here, oxygen would be the main product, with the resulting byproducts being nothing more than a potentially useful extra. So while we already know the basics of this chemical process, it's accompanied by a major complication. It's extremely energy intensive. To make the process of oxygen production on the moon sustainable, solar energy or other energy sources naturally occurring on the satellite would have to be harnessed. But the logistical and industrial effort involved in such an ambitious undertaking should not be overlooked. The first step is to liquefy solid metal oxides. This is typically accomplished by adding heat, solvents, and electrolytes. On our blue home planet, this can be done relatively easily. After all, we have the appropriate technologies here. However, transporting them to the moon and then generating enough energy to keep them running is a formidable challenge. Recently, the Belgian company Space Application Services announced plans to develop 3 new experimental reactors to improve the process of oxygen production by electrolysis. In doing so, the group aims to bring the relevant technology to Earth's steady companion by 2025 as part of ESA's ISRU mission. How much breathable air could the moon provide? Let's assume that the experts' efforts will be successful and they succeed in developing an effective oxygen extraction process along with the necessary sustainable energy source on the moon. Even in view of this optimistic train of thought, however, such a scientific milestone is still subject to a central question. Would it even be possible to produce enough breathable air on the moon to ensure the establishment of a large, permanent colony there? Of course, scientists have already devoted their attention to this fundamental issue. If we leave out the oxygen inclusions, which are hidden in the deeper rock layers of the moon, and direct our attention only to the uppermost layers of the regolith surface, some estimations can be made in this connection. Each cubic meter of lunar regolith contains an average of 1.4 tons of minerals. If we remember at this point that the oxygen content within these minerals is 45%, we can conclude that 1 cubic meter of regolith contains 630 kilograms of oxygen. According to the official data of the experts, an adult human being needs about 800 grams of oxygen a day to survive. With 630 kilograms of breathing air, a single person could therefore survive for about 2 years on the Earth's satellite. Let's assume that the average depth of the lunar regolith is 10 meters. Assuming that we actually succeeded in extracting 100% of the oxygen deposits contained therein, this would mean that the uppermost 10 meters of the lunar surface alone contain enough oxygen to supply no less than 8 billion people with the air they need to breathe over a period of 100,000 years. Possible colonization locales. As soon as the supply of oxygen is guaranteed, the question arises, which places on the moon would be suitable for the establishment of a human colonization? Generally, 3 areas are mentioned: the polar regions, the equatorial plain, and the backside of the moon. At the poles of the satellite, there are places exposed to an almost constant incidence of light. Because of this characteristic, the corresponding areas were called mountains of eternal light in former times. The sun could be used there as a constant source of energy. The Shackleton crater in particular comes into focus again and again. Beside the fact that some peaks at the crater rim are bathed in constant sunlight, there is potential water ice that could be used by a colony. Those areas that extend along the lunar crater in turn are characterized by their relatively easy accessibility. Due to the steeper angle of incidence of the solar wind, a higher helium-3 concentration exists there, which in turn makes the corresponding regions easier to reach, since no polar orbit is required for takeoff and landing. Here it is pure gamma, a so-called swirl, which could possibly be the location of a moon base. This area has a significant magnetic field, which weakens the intensity of the incoming solar wind. But also the legendary dark side of the satellite, which contrary to a persistent misbelief is not not plunged in permanent darkness, but simply passes through the individual moon phases the other way around, could be suitable for the settlement of the Earth satellite. The far side of the celestial body naturally offers good shielding against those radio signals that originate from our blue home planet. In theory, the operation of radio telescopes on the far side of the moon could therefore proceed without any significant interference factors. In this case, however, communication with the terrestrial stations would have to be handled via an elaborate satellite constellation. We want your opinion. What do you think about the oxygen supply on the Earth satellite and the potential colonization of the moon? We're already curious about your comments. Please also have a look at the other exciting contributions on our channel, which we have linked for you in the credits. Thanks for your interest, take care, and we'll see you next time.